Hi, this is for Casey. I'm trying to show how to do a regression on a data set using Desmos as the tool, the calculator. You can also use other tools. Excel does this, and graphing calculators like TI-84s and so on. They also do this. But that, if you're already familiar with the calculator, please, you can do it that way. I know that my math lab tends to explain it using the graphing calculator, but Desmos is faster and it's free, and I allow you to access it during a test. So that's what I'm going to show now. So let me see if I can get it to share the problem. This is similar to the problem that you were talking about. That's not the one. Well, is it going to show me when I'm sharing? Yeah, okay. So I don't, anyway, all right, so here's the data set that was given. It's talking about the year it is. This is kind of projections out into the future. And then underneath it is the projections of the number of people in millions, I think. What does it say? Millions of citizens that are going to have Alzheimer's by that year. Okay, and so it's asking us to come up with a model, a scatter plot, and then an actual equation that would model that data. So the scatter plot is just plotting those data sets together, and as each data pairing makes a point, and you have to adjust your X and Y grids to show the points. Now, somewhere when it asks for the scatter plot or the regression model itself, it's going to give you a start year. When our input values are years, we typically don't use the entire year when we're putting it into the table and into the scatter plot and the information for the regression equation, just because it's a lot of it's a little more tedious to carry these big huge numbers like 2040 while we're doing our calculations. So we usually pick a start year. This one has, it says create a scatter plot of the data with X equals the number of years after 2000. So the year 2000 is going to be our start number. So we're going to take each one of these years that are listed in the data, subtract the start year to figure out how many years after 2000 that year is. And that's the number we're going to put in for the X's for the table. So where this table starts off with the input values being 2000, 2010, 2020, when we go and build our table that we're going to use for our scatter plot and regression, we're just going to use 2000 as X equals 0. That's 0 years after 2000. And then 2010 will just become 10. 2020 will become just 20. We're taking the actual year, subtracting the start year, and that's the X value that we will use. Okay, so I have actually already done this. Let me see if I can switch to another screen here. So now, what's Desmos? If you haven't used it yet, this is what it's going to look like. You can go to something called desmos.com, and it will either show you this screen, though it's the graphing calculator part of the screen, or it may just show you the general website for Desmos. And if that's the case, you'll see math tools at the top. Click on that and select the very first one, which is the graphing calculator. So you can use it as a regular calculator by just typing in an expression that you want to evaluate. You can use this template down here. If I wanted to do what 3 to the 5th power is, I can hit 3 exponent 5. And it will just give you, it'll show you the answer down here. So you can use it like a regular calculator, or you can also use it to graph stuff. Like if I wanted to do a line, y equals 2x minus 12. So if you type in a f of x equals or y equals type of equation, it will show you over here the graph of it. What's nice about Desmos, it's better than a calculator. If you are looking at a graph, if you want to adjust it up just a little bit, like I can't quite see the y-intercept, you can just click on it, hold your cursor down or hold your mouse down, and then slide it up, and it will show you whatever parts of the graph you want. You can also zoom in and zoom out quickly with these settings over here in the corner of the graph. The standard setting is the little house there that will always show you -10 to 10 on the x-axis, and just a little past -6 to 6 on the y-axis. If I needed to adjust it quickly and like very high up, like maybe the y-intercept's at plus 150, and so I don't want to try to keep grabbing it and sliding it, that's what the little tool is for. You can go in here and you can manually adjust how far to the left or the right around your x values, or how far below and above the middle you want for the y values. So that's how you can manually take one side of this graph and extend it or zoom in on it however you like. All right, but what we're here to do is the regression. So when you have a table of data, you want to put the table into Desmos. So over here, you just type different things into each line and it will either show you a result or it'll show you a graph over here. So what you do is you just close everything that you've had before with the X. And then up here where it says add, you're going to add a table right there. So as you add a table, you're going to now, X1 is where you're going to type in all your X values, and Y1 is where you're going to type in all your outputs or your Y values for the table or the data set you're given. It has a little picture here with dots on it that tells us it's just going to try to remember these disordered pairs, and it will plot them on the graph if we had the window set up over here to show wherever they are. Okay, so if you might remember from our table before, the years were going to be start off like 0, 10, 20, 30, because we're adjusting for that start year of 2000. And then the output or the Y values started off 3.8, 5.7, and so on. So I went ahead and had that put into another Desmos window. This is our standard window over here on the right, and here's the information. I just typed it in by hand. Now, it did ask us to look at a scatter plot, and it gave us specific, let me see if I can pull one of these out. It says underneath our choices, it says, all graphs are shown in the window 0 to 50 by 0 to 20. And what that means is they want X to run from 0 to 20, and they want Y to run from X to go 0 to 50, and Y goes 0 to 20. So we could type that in by hand right here by clicking the little tool and typing the 0 to 50 here for X. 0, you have to kind of type over what's there, to 50, and that extends it. And you can see the first 2 points, we're starting to be able to see them a little bit. And then Y would go from 0 to, what was it, 20. So Y would go from 0 to 20. Okay, so I manually set that, and this is kind of what I'm seeing. What did it say? X scale was by 5s and Y scales were by 2. That doesn't really matter in the grand scheme of things. But the scale is how often do you want it to put a little mark? So it says X scales by 5. So that would be a step of 5. So now look here on the X-axis, it's going 5, 10, 15. Y value, it wants to step at 2. So if you look on the Y-axis, 2, 4, 6, 8. Okay. So this would, I guess I'll slide it back and forth to where it kind of looks like a square. I don't know if we need, but that's what we're going to see. It's kind of the second one, it goes up and then it kind of flattens out again. And then the last 2 points kind of show a steeper increase. That's probably why it wants a quadratic picture. But that is what we can match to the 4 choices that we have and pick the correct graph to get past part A. Another honestly faster way to do this that I would do it using Desmos, there's that last point there. I'm going to click on the little house again to get it back to that standard window setting again from -10 to 10. It's really nice. As Desmos, once you get your data in there, you have 2 options ready to go. The little magnifying glass that says zoom fit down here on the lower left side of your table will automatically readjust your window so you can see all of the points. So watch, I'm going to click it, click. To see what it did, it kind of zoomed out and put that scatter plot right in the middle of the graph. So even though that's not exactly the same window as what it asked for in my math lab, we can see that pattern pretty clearly. Anyway, so if we do that and compare it, there's only one of our 4 graphs that's just kind of marching up a hill like that. So we would pick the one that matches that to get to the next question. So the next question is going to be, though, the part you were actually asking me about, which is how to get those 3 numbers for the regression model. Okay, so again, if we look over here at our table, the zoom thing isn't here anymore because I used it to get the picture over here. But whether or not we want to look at the picture, if we want to do a regression, that's what this little icon at the top that has the dots and the line through the middle of it, that's what regression does, is it takes information from all of the points, runs it through some statistical formulas to come up with the coefficients for the curve that you want to fit through there. So the simplest one that people like to start with is just a line because it just never changes. It just starts up that slope and just continues forever. But you can also adjust it to whatever shape you want. And for this problem, we're in module 2. It wants us to do a quadratic regression. So if you look at the picture, it probably wants something that would look like a really spread open quadratic where this is just like the right side of the parabola as it's increasing somewhere after the low point or the vertex, and it's on the increasing right-hand side of the parabola. That's what I'm guessing. All right, so if we go over here and click the regression command, immediately underneath it, it gives you a linear regression model as the default type of model. And so if you look at it, we have right under where it says linear regression, it gives us, those are the coefficients for a linear model. The slope would be about 0.2 and the y-intercept would be about 3.2. And if you look at how it fits the points, I mean, it gets that general uphill trend, okay? But there's like several points that are kind of far off that line. They don't really hit the line, or they're not real all that close to the line compared with some of the ones that are very close to the line. So it's pretty good. But maybe if we put a little bit of curvature in that line and change it to a quadratic curve, it might actually fit closer to more points. So when you're asked for a quadratic model, you put your data in, then you click on the little regression icon at the top, and then you go down to the drop-down menu, unless you're doing a linear, and look at all the choices you have for different kinds of regression models. We wanted the quadratic, so we're just going to click on that second choice there, click. Now look at the equation. Now I have something that has a number times x squared plus a number times x plus 4. Well, that's a quadratic expression right there. And if we go over and look at the picture where it's graphing that equation, we still, maybe that second point is a little bit high off of the curve, but all the rest of them are really pretty close to that curve. So that's a little bit better fit even than the line. So that's why we're going to use a quadratic model to help us make predictions about maybe filling in the gaps between these years that we have the information on, or other years. So that's how you do it. You were asking me how you do it. You put the data, you go to Desmos. I'll go back to the other one. Go to Desmos. This is what you'll see when you open up the Desmos graphing calculator. You add a table. Once you have the table, you start typing in your X and Y values like this, and eventually it will look like, stop that. I'm trying to get it to you. It'll look like this. There's our table of values. And then once you have the table of values, you can go up to where it says add regression, and it will start showing you regression equations. So you just pick the type of model that you're being asked for, or that you think is most appropriate. Our problem asked us for a quadratic regression, so you select that. That's how you get the numbers. Okay, now you have to assemble them on your own when you're typing your answer into my math lab with the correct rounded values. I think they're just trying to help you, save you some time from having to type in the whole 10-digit value. And this was also the one I think where it asked for significant digits rather than just round to the nearest certain decimal place, but I already sent you an email about that. Okay, so Casey, I hope that helps you to figure out how you can take a data set and come up with an equation for the model that predicts those values or estimates those values the best. And my phone's going off. All right, so let me stop this and get this uploaded.